So this is the notes for the first part of your assignment for April 6th through April 10th. And what we first need to do is understand a little bit about rotation of angles and finding them on the unit circle. Where the beginning of this says find the exact value of each trigonometric function. What that's going to mean is that we have to find the location of this arrow on the unit circle. Now, I've provided you with the unit circle here up above, so we're kind of trying to figure out where on the unit circle does this number live. And once we know where it lives on the circle, then we can answer some specific questions. Before we understand why it works the way it does, or before we can do that, we need to understand why it is the way it is. So actually come down and we're going to kind of talk about this unit circle here. The reason that we call it a unit circle in the first place is because the radius of the circle, or the length from the center here at 0, 0, okay, out to the edge, if we came all the way out, this is a radius of 1. So we call it a unit circle for that reason. Okay, maybe it would have been better. This length out is 1 unit, so it's called a unit circle. Now, one of the things that we can come to really understand about this unit circle is that there's technically thousands of angles we could use, but we're only going to use very specific ones, and they're all based around 3 specific measurements. Well, technically 5 if you count a 0-degree angle and a 90-degree angle, but the 3 big ones are here in the middle, and the first one is here at 30 degrees. So at a 30-degree angle, we would follow this line out, okay, and it would intersect the circle at a specific point. It specifically is, this is 0.866, but it's the square root of 3 divided by 2 and 1/2 for the y value. That is to say that the x-coordinate is out root 3 over 2 and the y-coordinate is up 1/2. Okay, so if I were to go back up to the unit circle and look at that 30-degree angle, okay, notice the x is root 3 over 2. That's how far to the right I am to get right underneath it. And the y value is 1/2. That is exactly how far up my triangle would go. So we can see there's a right triangle here. And this is true for all of these. We can always create this right triangle. And so if we came back here and we said, okay, there's our 30-degree angle right there. Okay. This adjacent side that we've called the adjacent side for a long time, ADJ, our adjacent side, turns out to be the same size or length as the x-coordinate. In other words, how far over we are, our x-coordinate is the adjacent side. We also learned that the height of our triangle, the vertical piece, which is the y value, would be the opposite side. Okay, I'm going to rewrite this here in a second, but I'm just trying to write as I talk. But that this y value is the opposite side of the triangle. And so if we have the adjacent being the x and the opposite being the y, then this hypotenuse, if we think about the circle in a bigger picture, this would be the radius, okay? But we already said that this circle was special because the radius of the circle was going to be 1 unit, and so it is 1. So this root 3 over 2 and 1/2, they're numbers that are specific because the radius is 1 and we're using a 30-degree angle. If we come back down here to this picture, we could create the same triangle for every single one of these angles as we work our way around. But a couple things that we have to keep in mind. I'm going to jump over to handwritten here for a minute. Okay, a couple things that we definitely want to keep track of. The first thing is that on the unit circle, the light just got down. Let me flip the light here. Oh, light's already on. Sunlight's going down. On the unit circle, get some sunlight back. On the unit circle, specifically in capital, the opposite side is equal to the y coordinate. the hypotenuse side of the triangle is equal to the radius, which is always equal to 1. Okay? So when we define number sine is equal to the hypotenuse, a new definition for that would be the y coordinate divided by the radius, which is 1. Well, anything divided by 1 is the side, so it's y. So literally, if I ask you sine of 30 degrees, all I have to do is go to the unit circle to 30 degrees, jump over there, to make sure this all makes sense. Go to 30 degrees on my circle, find the y coordinate, and that right there is the sine of 30. It's 1/2. And we can put that in the calculator. We'll do that here in a minute. If we put that in the calculator, the sine of 30 will be 1/2 every time. This is going to give us some exact answers for some very specific angles. This isn't going to be for everything. I'm not going to ask you about a 10-degree angle. But ask me about a 30-degree angle? Yeah. And a 45 and a 60, a 135, a 150, anything that's on the circle, you should be able to find your way through the triangle, through the circle, to come up with these measurements. So in this case, it's 1/2. I can answer questions like that. The next one is the cosine of the angle was defined as the adjacent over the hypotenuse. So the adjacent we just learned is the same as the x-coordinate. And the hypotenuse is again the radius, but the radius is 1. This means the cosine is the x-coordinate. The sine is the y-coordinate. And last but not least, we're going to focus on the tangent, which is equal to the opposite over the adjacent in our earlier definition. But the opposite side we just defined as being the y-coordinate over the adjacent side we just defined as being the x-coordinate. And there's no shortcut here because y over x is y over x. We're not going to be able to simplify that. Depending on the problem, we're going to have different answers and results. There's the information that we have to have kind of going into the beginning of this worksheet. That we can go to the unit circle and we can find these specific information. Okay, I'm going to do some that aren't on the circle or that aren't on the assignment because again, I want you to really be able to stretch as you go through the assignment. Let me jump in here real quick and clear a bunch of this nonsense that I did a really bad job of writing. Here we go. And then we'll jump down here, do the same. My handwriting with a mouse is not ideal. We're just going to say that. We're going to go back to there. I'm going to pause it. Okay, so now we're back to the actual solving of some of these problems. Let's take a look at, let's do question number 1. Well, not number 1. Maybe I need to do number 1. Yeah, we'll do number 1, just so you guys are comfortable with this idea. So the first thing we have to do is understand what is, it says negative 11 pi over 6, but I need to know what 11 pi over 6 is. Now keep in mind, all of these are on the circle. If I come up to my unit circle, I can find 11 pi over 6 right here. And that is the same as 330 degrees. Most of you are going to be way happier using 330 degrees. Now I do need to go backwards, so negative 330 degrees. If you start at 0 and you go backwards 330 degrees, that should put us plop right about there. Right here, back at 30 degrees. Well, I'm being asked to find the sine of this angle. So I go to this location and I remember that the sine is the y value. That's how we defined it earlier. Well, the y value here is a positive 1/2. The answer to question number 1 is 1/2. Now let's look at an example of a problem that maybe is a little bit different. So I'm going to grab back to my paper and we're going to say we're going to do tangent of, let's say, 60 degrees. Okay, this is a really standard type of test question because it's not so complicated, but it does take some time. You do have to set up the algebra correctly. So we're going to go back to our unit circle. Whoops, go to our unit circle. Here we go. We're going to go and we're going to find 60 degrees. So let's get rid of this nonsense. Don't need this anymore. 60 degrees would be right here, which means we're using this ordered pair. Now the tangent has been defined as y over x. My y coordinate is root 3 over 2. My x coordinate is 1/2. So I'm going to take my paper here. Maybe I should split screen this a little bit. Let's get rid of that. All right. So I'm going to try to do this right. Doing this live while we're doing it is a little bit different, but we're going to get this set up just right. Okay. Okay. So you can hear my kids in the background if you're real observant. But anyway, we have to do the y over the x at 60 degrees. Well, the y value at 60 degrees is root 3 over 2 over the x coordinate was 1/2. And so what we're going to do is we're going to stack them like this. Now, guys, we can't leave a stacked fraction like this. What we're going to do is we're going to times by the reciprocal of the denominator. If it makes you feel better, I'm going to actually write this in really longhand. I'm going to times by 2 over 1 on top and on bottom. On bottom, these cancel. And I'm left with root 3 over 2. Not in your room. Get out here. Okay, sorry, my kids are on the meeting. Okay, so what we're left with is root 3 over 2. I'll try to make it a little bigger. Times 2 over 1. It's really common that you'll see the 2's cancel even on diagonal like this. It turns out it's 60 root 2. And there's our answer to that question. So if it's a sine, you're just taking the y value. If it's a cosine, you're just taking the x value. The tangent becomes a little bit trickier. Remember, 0 over 1 is equal to 0. But 1 over 0 is undefined. We don't know how to divide by 0. You can't divide by 0. So those are our two different what if scenarios. But this should be enough to get you through the first 10 questions. You'll notice in the homework, the first few have a picture, the first 5 have a picture, the next 5 do not. But all the way through question 10, this is still what you're doing. Good luck, and come see me during conference hours.